Okay, we're going to continue where we left off in the last video. And we saw previously that the elevation of the northern hemisphere of Mars was much lower than the southern hemisphere, and that the surface of the northern hemisphere was a much younger surface. One thing that may have contributed to that was we believe that in Mars's ancient history that there may have been a very large ocean of liquid water on the surface of Mars, and that ocean may have basically filled in that lower levels. The northern hemisphere may have been largely an ocean a long, long time ago. But if there was water on the surface of Mars millions and millions of years ago, what happened to it? Where did it go? And so part of that is what we want to talk about over the course of this video, and talk about how Mars has changed over the years. So one of the things that we can note is that in this region, impact craters less than 5 kilometers across have mostly been eroded away. And by analyzing the craters on the surface, it allows you to estimate the age of that surface, as we have talked about. And here we see a couple of images showing cratering, and the crater on the right was made when the surface was liquid, it is believed. Now, recently, we can see the formation of features on Mars that are generally created by water erosion. And so, for example, gullies have been seen, and that seems to indicate the presence of liquid water on Mars, but that interpretation is in doubt, but maybe there's something to it. What is really interesting, though, is that we have a couple of images here of the same segment of land, and we can see that there are geological changes. This first picture was in 1999, the second picture was in 2005, and we can see the changes here show that sort of erosion, which suggests that maybe gully formation is ongoing on Mars even today. So maybe as Mars warms up in the summer, that some water melts and is able to do geological things before it evaporates into the atmosphere or freezes back down. And here we see, again, we've talked about the polar ice caps, how it is believed that they are largely frozen water ice covered by frozen carbon dioxide. And as I mentioned previously, in the southern hemisphere, there's a much higher amount of frozen carbon dioxide. And of course, we know that's dry ice. It's just another name for frozen carbon dioxide. The polar ice cap in the northern hemisphere seems to have more water and less carbon dioxide ice covering it. But both of these images were taken during what was the summer. So the northern hemisphere and the southern hemisphere have summers at different times, obviously, but each of these pictures of the southern and northern hemispheres, respectively, were taken when it was summer at those locations. Now, moving on, we can see here is an image taken from one of the Viking space probes that was landed on the surface of Mars. And again, it seems familiar to us here on Earth. This is not a picture that looks entirely alien, but one of the things that is weird is this stark red color. Mars is often referred to as the red planet, and it is covered in soil that has this reddish hue. And the reason that the surface of Mars has a lot of red in it is because the soil contains a lot of iron oxide. When iron interacts with oxygen, it forms this compound which has this very reddish color. Now on Earth, we see iron oxide forming as rust. And so the rust that you might find on a piece of iron, like an iron tool or something like that, that reddish hue, that's caused by that iron oxide. And that chemical is present in abundance on the surface of Mars, and it makes Mars seem very, very reddish. Here's a closer up feature of Mars, And you can see these rocks and boulders that litter the landscape here, but it's familiar in the sense that you could imagine walking across this surface and it would in some ways feel a little bit like home. Of course, in other ways it would be very different. Here we see a shot that was taken by the Opportunity space probe, which has been there a while. It actually landed in, I think, 2004, 2005, somewhere around there, and it has been going for, well over a decade. It was active all the way from about 2004 up until about 2018, which is when we lost contact with it, but that was a very long time that little probe has been wandering around the surface, investigating what we can find out about the surface of Mars. The Curiosity probe is another probe that landed on Mars. We can see a picture of it here. So we have sent several of these types of probes to the surface of Mars. They're not just looking for water, but that is one of the things that they are looking for, finding evidence that water might still exist on the surface of Mars. Now, much longer ago, we landed probes called the Viking probes, and they also looked for evidence of living organisms on Mars, but alas, they did not find anything conclusive either. But of course, the search is ongoing. Now, one of the things that was a major discovery made some years ago was that they found this Martian meteorite in Antarctica. Now, you may wonder how that happens. Imagine there was some impact, the kind of thing that would make a crater on Mars. That caused a lot of debris to be thrown up into the air. Some of that debris was given so much energy it was actually able to escape Mars's gravity. Now, keep in mind, Mars is a much smaller planet than Earth, so it has a much weaker gravity. So this meteorite basically got blown off the surface of Mars and went into space, and it eventually intersected the Earth's orbit and landed on the Earth, and it was discovered, and when they realized what they had, they were startled. But even more startled by the fact that when they examined it, they found these carbonate globules that you can see in the picture here. This was a structure that was found, and on Earth, in these kinds of rocks, when you see these carbonate globules, they can be an indication of the presence of certain types of microbial life. This was a very, very exciting discovery because it suggested that maybe there is some kind of bacterial life that exists on Mars independently from the Earth. But later investigations have shed some doubt on this because there are other non-biological ways in which these structures can form. And so, is this evidence of life on Mars? Maybe, but now it seems less certain than maybe they felt that it did originally. But it certainly is a tantalizing idea. And so now we can look at the Martian atmosphere, and we have this graph that we've seen many times before now. We have three different axes. On the left vertical axis, it shows the altitude above the surface of the planet. On the horizontal axis, it shows the temperature in Kelvin. Typical room temperature on Earth would be, about 290 Kelvin-ish, something like that. And so you can see that the surface of Mars is at 250 Kelvin. That's the average temperature. It does get higher than that, it gets lower than that, but that's sort of the average temperature at the surface of Mars. And we see that Mars is really, really cold. Now, the Martian atmosphere is primarily made up of carbon dioxide. And so you might ask yourself, if carbon dioxide is this greenhouse gas, if it's responsible for global warming on Earth, if it is responsible for the runaway greenhouse effect on Venus, why is the Martian surface so cold? And there are two reasons primarily for that. The first reason is that Mars is simply far farther away from the sun. It doesn't receive as much energy from the sun to warm it up. But also, the atmosphere of Mars now is very, very thin. There is no magnetic field surrounding the surface of Mars. And so the solar wind, all these charged particles coming from the sun, are constantly pummeling Mars. Now, on Earth, we are also subjected to the solar wind, and we saw how our magnetic field redirects those charged particles from the solar wind away from the Earth. Some of them get trapped in the Van Allen radiation belts, but most of them harmlessly get shielded away from the Earth by the Earth's magnetic field. On Mars, they don't have that possibility for that kind of protection. And so the solar wind is constantly pummeling the atmosphere of Mars. Add to that, the gravity of Mars is very weak compared to the Earth. So the escape velocity on Mars is much lower than the escape velocity on Earth. So it's much easier for the atoms and molecules that make up the atmosphere of Mars to get enough velocity going so that they can essentially leak off into outer space. So the solar wind is basically pummeling Mars, and over the millennia, over millions and millions of years, it slowly eroded away the atmosphere of Mars. And now the atmosphere of Mars is very, very thin. So when you're looking at the pressure in Earth atmospheres, so one atmosphere would be the pressure at the surface of the Earth. If you go to the surface of Mars, it's 0.006. So that is 6/1000ths of the pressure at the surface of the Earth. If you were to find yourself magically teleported from Earth to the surface of Mars, basically the gases in your blood would start to boil, and you would get a condition called the bends. This happens to deep sea divers when they go down to very far depths in the ocean, and they come back up to the surface too quickly, and their bodies don't have time to adjust. Their bodies are used to the pressure at the ocean, and they come back to the normal atmospheric pressure on the Earth, and their gases in their blood literally starts to boil away. The same thing would happen if you were to be teleported from the Earth to Mars, because the pressure at the surface of Mars is so light. And the reason for that is because the atmosphere has been worn away. It's an incredibly thin atmosphere compared to the atmosphere of the Earth. And one of the consequences of that is because the atmosphere is so thin, it just doesn't retain heat very well, even though it's made up of primarily carbon dioxide. And so at nighttime, when the sun is no longer shining on the surface of the planet at that position, the heat cannot be trapped in, and so the temperature at night on Mars drops very, very rapidly. But as different as Mars is from the Earth, there are similarities. So Mars, as I mentioned earlier, does have windstorms and sandstorms, just like you see on the deserts of Earth. Mars has fog that can exist, and so here's an image showing that. Okay, so we have talked about the greenhouse effect on Earth and how that warms the surface of the Earth, and how as we put more carbon dioxide into our atmosphere, that's causing global warming. We've talked about how this effect has gone haywire on Venus and caused tremendous heating of the surface of Venus. But on Mars, the greenhouse effect seems to have worked in an opposite way, because as the surface of Mars got cooler, the water ice froze, and that made Mars become more and more reflective. So more of the sunlight that hits Mars, instead of heating up the planet, gets reflected into space. And as its atmosphere got thinner and thinner, eventually it got cold enough for the carbon dioxide in the atmosphere to freeze as well. And so we've talked about how the polar ice caps of Mars, that in the winter when it's dark, the carbon dioxide in the atmosphere freezes down over the ice caps and covers them up in a layer of dry ice. And so this is sort of the opposite of what we see on Earth, where we have global warming. On Mars, they have this more natural process of global cooling. So in Mars's ancient history, it seems though it probably had a much denser atmosphere and possibly liquid water on the surface and higher temperatures. So that would have made Mars, in a way, much more Earth-like. And just as life has been able to flourish on Earth today, maybe in Mars's distant past, life flourished there as well. And that gives us hope that we will someday find evidence of that life. Maybe even some of that life managed to survive. There are some very inhospitable environments on Earth where life is flourishing, and so maybe in some cave or underground or somewhere you'll find life existing. Or if not life itself, some evidence that life did exist in the past. And if we are able to discover evidence of either current life or past life on Mars, that would be game-changing. Because as I've said many times before, once we discover life somewhere outside the Earth, that means that the Earth really is not special in that sense. And that life can exist other places, and if it exists in multiple places in our own solar system, that would really suggest to us that life is everywhere throughout the universe. And that would be a really exciting prospect. Now, we do know a little bit about the Martian internal structure, not as much as we do about the Earth, obviously, but we can say that no seismic studies have been done, but from the behavior of the crust that we've seen, it's estimated to be about 100 kilometers thick. There is no magnetic field. So, of course, the Earth we talked about has this very large magnetic field. And I've talked about how the Earth, I joke and say that the Earth is a big ball of iron covered in dirt. But, that's one of the reasons why the Earth has such a strong magnetic field, is because it has this huge metallic iron core, and it has the liquid core where you have liquid molten things spinning along with the Earth, creating these electric currents that produce this magnetic field around the Earth. But the fact that Mars doesn't have a magnetic field suggests that those things don't exist on Mars. So the core of Mars is probably not metallic like the Earth's core, and it's probably not liquid either. So those are things that we have been able to infer. We don't know them with certainty, but we're pretty confident that that's probably the case. And the last thing I want to mention, we've talked about Mars, the planet itself. Mars also has two small moons. Those moons are named Phobos and Deimos. And Deimos was probably captured from the asteroid belt. There is a large field of asteroids between Mars and Jupiter. And Phobos may have formed later from material ejected from Mars by a meteor strike. So that may be the origin of the moons of Mars. But anyway, Mars does have two moons, Phobos and Deimos. And that brings us to the end of our survey of the Martian planet.